Okay, this video is a brief introduction into experiment 1, part B. The purpose of part B is for you to correctly measure the electrical resistance of a wire. Now this wire, normally when you measure resistance is measured simply by taking two leads, hooking one lead to each end of a resistor. It puts a voltage through it, and using V equals IR, the resistance is computed. In this case, if you go ahead and you try to find the resistance of this wire, hooking it up to these two leads, making sure that your digital multimeter, which is this is a larger version of the battery powered digital multimeter used in part A, you press the button that has the symbol of ohms on it, which is a measure of resistance, and you'll get the resistance of this wire using what's called a two-wire method. Basically hooking up two leads, one lead to each end of the wire. You're going to find that the resistance is not going to be correct. You have no point in referencing that except for me telling you that it's not going to correctly measure the resistance. And part of the reason is due that this quote-unquote resistor, or the metal wire, actually has a resistance that's probably less than that of this entire lead. So what you need to do is to be able to isolate the voltage drop across this wire, whereas right now you're getting the voltage drop across from this wire to that wire all the way through the circuit. And normally that's not a big deal as long as the resistance of the resistor that you're measuring has a resistance much greater than that of the leads. That way you're getting, if you get the voltage drop across the leads and the resistor, well, it adds up such that the resistance of the leads are negligible in comparison to that of the resistor. So let's say, for example, these wires are 0.05 ohms each, but your resistor is 1 mega ohm. Well, as you can tell by the simple math, 1 mega ohm is millions of times greater than that of the resistance of the leads. So when you measure the voltage drop, which is what the multimeter does, it measures the voltage drop across the leads through the resistor. Well, guess what? The leads are not adding much resistance to the resistor. So effectively you're getting what the voltage drop would be across the resistor. But this is not the case because you have a quote-unquote resistor here where the resistance is actually less than that of the leads. So if you're getting the voltage drop across the leads and this wire, well, you're not getting a representative voltage drop across just the wire itself, again, where the voltage drop is necessary to compute the resistance. So you use what's called a four-wire mechanism, or a four-wire method. You hook up two more leads to the end of the resistor, and then in being able to find what that resistance is, you would press shift here and then press the same button again. As you can tell in blue it says 4W, and black it says 2W. 2W means two wire, and 4W means four wire. So you're going to find that when you use the four-wire method, I'm not showing you exactly how to do it as far as hooking up the wire and hooking the leads to the wire. I'm sure you can figure that out, but you're going to find that the resistance is about 1/10 of that of what it was with just a two-wire mechanism. And so part of your goal is to figure out why that is and how this works. Okay, that's the end of instructional video for experiment 1, part B.